which means I need to get out of this section.
What? You can talk. You don't need to whisper. It's recording all of this too. It sucks. All right. Oh. I should I should have been ready to roll. All right. I'm almost ready. I'm almost ready. Oh God, there it is. I'm covering up this, so it's okay. All right.
There we go. So we're going to go to this page. The trig ones are going to be very intuitive, and there's some you need to memorize and some you don't. So what I'm going to suggest you do first and foremost, and I'm going to suggest it actually for almost everything you do from here on out, is to go on the side, whether you're taking a test. I've got the spinning wheel of doom over here now. I'm going to regret recording this because my smartboard's got it. Okay, I would go write this Saint Cloud, negative Cloud, and it ends the same way it starts. I would start writing that on almost everything you do because you're going to get sick of thinking the SIGNS's, like the positives and negatives of these, out. And this, it's built in. Remember, our derivatives go this way, so the derivative of cosines, negative sine, etc. The integration goes up the scale, so it kind of gives you all the derivatives and all the integrals of cosine and sine. So having said that, what do you think the antiderivative of sine is? It's negative what? Cosine x plus our good friend Kyle. Yep, you just read it up the screen. Same here. What do you think the antiderivative of cosine would be? Sine x plus c. So this gives you all things sine and cosine. This one we just talked about. I said the derivative of what is secant squared, and you guys just knew intuitively it was tangent, so that's awesome. What do you think the next one is? The antiderivative of secant tangent? No. The derivative of what is secant tangent? Secant only, yeah. So that one would be secant plus c. Those are the four you need to have memorized. There'll be some more later, but that's all we can work with right now. So those four, memorize. They're fair game on the AP test, on my test. These two are fair game on your worksheets and homework, but I won't test you on them because College Board says you don't need to memorize the cofunctions. But go with your gut. If secant squared's antiderivative is tangent, guess what cosecant squared's is? Negative. Thank you for, you're the first one today. Everyone always says cotangent. I say, well, close. The cofunctions go negative. You can even see it with sine's derivative being cosine and cosine's being negative. So good thought on that one. Go with your gut on this one. So you don't need to memorize it, but go ahead and see if you can just think it out. Because you know the one that's not the cofunctions, you actually should know this one. It just becomes a, go ahead and, what do you have there, Savannah? Negative cosecant. Yep. So these bottom two you can feel free to look at any time. I promise I won't put those on a test, and College Board will not put those on your AP test. Good enough? So on the next page, we're just going to go do a little practicing with some of the trig stuff. So let's go to number 2 first, actually. Don't make up your own rules. We have a rule that says you can break subtraction into 2 of them. So you don't need to physically break it like I'm doing, but you at least can think of it as 2 separate integrals. So I am going to write it like that. And now this part right here we did on Monday. What's the antiderivative of t squared? Go ahead and tell me, Elizabeth. What's t squared's antiderivative? Yes, t to the third over 3, or 1/3 t cubed. Same thing. Technically plus c, right? I'm not going to write it though, and I'll tell you why in just a second. What's cosine's antiderivative? And again, if you just take 5 seconds to write that on the top of everything, you don't have to keep thinking them out. What's cosine's antiderivative? Sine. So this would be minus sine t. Now suppose Carter thought of this as plus and negative, right? Which is totally legal. He would be doing negative cosine's derivative, which is negative. So either way, whether you think of the negative as attached or detached, it'll work out the same. What did I forget? Carl, and technically there's one on here and one on here, but what is any constant plus or minus another constant? A constant, yes. We just call it one constant on the end. So the moral of the story is the trig ones are really easy for now because there's not much we can do with them. But here's what I'm gonna put something on here for a second. This should seem, don't write this down. Are you ready? Here would be a function from, let's say, last chapter. If I told you to find the derivative, and let's say Claire is just out to lunch, and she says, oh, the derivative of 4x is 4, and the derivative of sine x is cosine x, and she moves on to the next problem. That should feel awful to you right now, right? What rules should be applied? Product when you know that, but this was very common on the first day of the product rule. People were doing, even on the test, a couple people I wrote in big shouty caps, like, use product rule for a product. Making up your own rule because it looks good is now going to come back and haunt you in integrals as well. It'll eventually, like, this is awkward for almost, it's bad, right? But this one right here, don't make up your own rule. We don't have one for a quotient, correct? And I never said you can do the top and then do the bottom and work with them separately. You actually have to integrate that as a full integrand. So here's the problem. As it looks, it's not on our chart. But I'm telling you it is on the chart if you play with it. So I want somebody to tell me which one that really is. It's just disguised. So go play with it. Shh. I want people to play with it because you can't do it unless it's one of those 6 I just listed on your chart. You only have 6 trig ones. You know it can't be sine or cosine because we've got, so which one is it in disguise? You've got it. How did you know it was that, Mike? Yeah, he's seen a split. He knows it's got to be on the chart. He knows it's not one of the first 2. So he's trying to work with the tangent secant stuff, which he can do if he just has a little bit of trickery in him. Correct? What is this really right here? That's tangent. Yep. And what is this guy really right here? Secant, and that's on the chart. So what's the antiderivative of tangent secant? We try not to look for the top 4, and it's in the top 4. Secant. Yep. So this would actually end up being secant. So when you're doing the trig ones, I'm going to tell you this would just be secant x plus c. If you're either going to know it, it's going to be like this. Here, go do this one. Let's do integral. Let's make a negative just because people tend to goof up with that. And let's do, I'm going to do that. I'm going to have you practice it a little bit here. Minus, and then let's say sine x dx with a 7 in front of it. Go integrate that on your own. It's got 1, 2, 3, 4 integration rules in it. If you're listening to the video, they're working right now. So if you're watching the video, you should try it too. So I want you to use your rules correctly with negatives, with negative fractions, and then I threw a very easy, straightforward trig guy at you. This is kind of what your worksheet's like. It mixes the trig with the other stuff. Let's begin. How about Riley H? How do I integrate x to the negative third? Sorry. What do you mean by that? Thank you. I think you were telling me a derivative. So, I don't bring it out front. I add 1 to the power, and then I divide by that power. This one, I have to see the power first. So in my head, I'm thinking, or I'm writing above it, x to what power? Negative 1/2. Yep. I still add 1 to it, disguised as 2 over 2. Agreed? So I actually get plus x to the 1/2 divided by 1/2. So what do? Instead of dividing by 1/2? Yep, Joe, multiply by 2. Perfect. Then this guy, constant multiple rule. We have a rule that says you don't need to mess with constants. They just stay there. And then you just need the derivative, antiderivative of sine. Sine, cosine, negative cosine, sine. Up the scale, right? What's the antiderivative of sine? Negative cosine plus Carl. Anyone get that one right in full? It's actually still got an issue. I should actually do this. 1 and then the x squared, right? Get rid of that. Awesome. So let's move on. Let's go to the next page. Now there's a bunch of vocabulary and language here that's super important for chapter 6. So, and we're only in chapter 4. So I have to introduce, I'm going to go back to, let's have little Elizabethan, 5th grade-ish. Maybe she learned this because you're a junior, right? Yeah, this was probably a while ago. Way back when she first heard the ugly word algebra and you're hearing the ugly word calculus, when she was taught to solve this, right? What does your answer look like when you're done? Whenever it would say solve, what's your answer look like? X equals, okay? On a much grander scale, when it says to solve what's called a differential equation or find the solution, it means you want to know what the original function was. It means I want to know what was y. I took its derivative and got this, but I want to know what it was. Now watch, back to little Elizabeth, right? Elizabeth, your teacher said, you know what, honey? If this is minus, you need to what? Add. And, little Bethy, you need to do it to both sides, sweetheart, right? Because otherwise it's not balanced. Agreed? We're going to do the same thing. And then she'd go, oh, 2x equals 12. But I'm not done. Right? Because then she'd say, oh, and the teacher would make you show, I'm assuming, show every step, right? Now that she's done it a long time, she looks at that, solves it in her head, and says x is 6, right? But we're going to go back to solving, and we're going to show everything today, and then I'll tell you what eventually you can chuck. Is that fair enough? So you might be going, I know how to undo a derivative. That's really what you need to do. You know y's derivative, you don't know y. How do you think we undo a derivative? Integrate, right? And Claire, you could just say, I can integrate that. I can do it in my head. X to the 4th over 4 plus x squared over 2 plus c, done. But I don't want you doing that, okay? I don't want you just looking at this and saying it's 6 and putting a 6 on your paper. I want you, for another chapter's purposes, to actually show it with the correct process. So I want you to write this correctly down and do what we did last chapter. If I'm trying to isolate y, which is what it means to solve the equation, I want to know what's y. I want to get the dx out of there. So last chapter, remember last chapter I said you're eventually going to see why we're whipping that dx over. We didn't really do much with it, but I said it's for integration. Now, I'm going to go back up here and I'm going to do the equivalent of adding 1 to both sides. I'm going to undo this differential or this derivative. To do that, I will integrate, but I have to integrate on the left and on the right. It's kind of like adding 1 to the left and to the right. In here, there's really a little invisible one. So this question goes to Ashley. Ashley, if I asked you to integrate 1 with respect to x, boy, that's a bad integration symbol, but if I asked you to integrate 1 with respect to x, what would you say the answer is? X plus c, right? So guess what it is when it's with respect to y? Y, yeah, so I will have y, and you're going to be tempted just to say, just to go, I want you to get used to writing this out for a reason. So it'd be x to the, and you guys trust me enough where I think you usually do everything I suggest, which is kind of nice. All right, what did I forget? Carl, and it's super important for a distinction here. Right here is what's called a general solution. It's actually a whole family of functions. How many of them? An infinite amount of functions whose derivative is this. That's what it means to solve the differential equation, is get the original back. In the real world problems, we're going to know the rate that the bacteria is growing, dB dt, right? When we solve it using integration, we'll get a function for just b, the amount of bacteria there. Do you see its power? Like, it's super powerful. Anything where you can chart a rate of change as time goes by, when you integrate that, you get how much. That's why you need to take calculus for like economics. Guess what's growing over time? Money, right? And so that's why calculus is kind of an Oompa Loompa for all those engineering, and things are changing all the time over time. So we're just getting the mechanics of it, but understand that when this becomes dB dt equals, and it's some function of time, to solve it means, hey, I want to know how many bacteria there are at any given time. And to do that, I integrate. So back up to here. This is the general solution. I then graphed 7 different C's. I had a C of, looks like 3 and a 1 and an 8. Do you see all my different C choices? And I put it in Wolfram and I just graphed it for you. These right here, each one on its own, like this guy right here, is called a specific solution. All right? So once you get a C, It's become specific. In order to get the C, though, guess what they have to tell you? What do you think? What do you think you have to know? A point on the curve. So they'll lock you in to one of the infinitely many solutions by saying, hey, you must go through this point. So in order to do that, all you do is take your general equation and force it to go through that point with substitution. You say this, I need to get a 13 out because it says y's are equal to, and I'm putting in a 2 for x, so mine has to work in this equation. Do you get the process? Because procedure is going to be, it's an easy process. It's more that I want you to understand what you're doing. So you guys go solve for C. Go tell me, this would imply that C equals, I don't want to do the arithmetic. I'm just feeling lazy today. Looks, what is it? This was supposed to be to the what power? 4th. Sorry, I wrote it down wrong. It was x to the 4th over 4 plus x squared. It's a 7. Do I have a background of 7? This is not the answer. All right, that's just Carl. Your actual solution is back to the original. The function y equals x to the 4th over 4 plus x squared over 2 plus 7 is the one function in the whole world whose derivative is as it should be. What do I mean as it should be? What should the derivative of mine be? Go ahead and look. X cubed plus x. And it goes through the point given. So let's go down and make sure you understand the distinction. When it tells you to find a general solution, what's always in your answer? Yes. When it tells you to find a specific solution, what do they have to give you so you can do that? You'll be given a point. So if you're not told, if it just says the solution, you'll know if they tell you, you will be given a point, and basically it means you're going to have to go figure out who Carl is. So find Carl. I don't know why I put an exclamation point there. Find Carl. Yes! All right. So let's go take a look at how it works. So I told you the book work is extra credit, right? Did I tell you guys that already? Yes, I forget. You're my last hour. I've said things a zillion times today. It would be due tomorrow. This is number 62. So there's also 4 of these on your worksheet that I'm going to pass out. I want to know, the directive on this would have said solve the differential equation. A lot of times when you take a class called differential equations, they call it diffie-qs. So solve the diffie-q. Basically, take a look at this. Where is my function? Is it in f, f prime, or f double prime? Yes. I have told you what the second derivative is. Do you agree? I want you to figure out what the original function was. All right, now let's talk about that. If I know the second derivative is x squared, what do you think the degree of the original was? 4. Yep. So let's talk about if I take a derivative and a derivative to get here, how do you think I go back? Because I want to know what is f of x. I'm going to integrate twice, and I'm going to do it with really good notation. I know Brad could hop on there and go, x cubed over 3 plus c, and I got the c in my head. I don't want you to do that. Proper notation for later in the year is very important. You're going to do what little Bethy had to do in elementary school. She had to write the problem down. Basically, write down what you are given. Start with where your function is located. Then you're going to show me that you're integrating both sides, right? Just like showing me you're adding 2 to both sides of an equation, which you don't do anymore, and there might be a point where I let you stop doing this, but I want you to do that. All right? What do you think the antiderivative of f double prime is? Yeah, the derivative, oh, you see what, this actually going from here to here, there's a reason for it. All right, perfect. What is the antiderivative of x squared? X cubed over 3 plus what? Carl, this is called a general solution for f prime. Now guess what I need to do before I move on? Find c, right? I'm going to get on the actual f prime. How do I do that? Plug in the point. Yeah, it's an easy one. I purposely kept them 0 so you're not like in arithmetic nightmare. But I need to get an 8 out when I put in a 0 for x. So what's c? 8. All right, so here's my specific solution for f prime. Are you okay with that? Next up, I need to do it again. Why do I need to do it again? Because I want the original function. All right, so I would say I need to integrate u, x is my variable of change, x is my variable of change. What is the antiderivative of f prime? F. Now, here we go. F of x equals, and I'd have x to the 4th over 4 times 3. You should be fine with my derivatives, right? Plus 8x plus what? C. What's that called in blue? Just for language. That's oh, you guys are so awesome. That is a general solution. It's infinite amount of functions whose second derivative is what? X squared. Okay? Now, if I go get the C, and again, how do I get the C? I go hop on the specific curve, right? Some books will call it a particular solution, but I need to get a 4 out when I put a 0 in. So I don't need to show the work for that, right? What does C have to be? 4. So here is my answer. And I want to talk about what this answer, I really want you more to understand what this answer is, not how to get it. I know some of you maybe could have even done it in your head. Don't really care. First of all, I want you to know that's called a specific or a particular solution to a differential equation. That's the language behind it. You got that down? Here's some properties that it has. I know its second derivative. What is its second derivative? X squared. Go take it in your head. Bring the 4 out front, knock that down to a 3, and then we have an 8. The 4 would be gone. Derivative number 1, right? Derivative number 2, the 3 would come out front, and I get 12 over 12. Do you see how it's going to work? And it'd be x squared, and then it works. What else is true about this function? I know its second derivative. Give me something else I know about it. It sails through the point what? 0, 4. Yes, awesome. So let's go to the next page. Here we go. We're not going to do the physics today. So this would normally be day 2. We're lumping it into day 1, and I'm just going to have you go try a couple on your own. I want you to go do that one right now. So again, if you're watching the video, go do it while we're waiting. Just the circled one. Give me the antiderivative of negative 2/3 cosine x. That should be very straightforward. You should probably even be done by the time I say you should be done. We're good, right? I heard the pencils click. So what do you think I'm going to suggest you do with this constant? Really, it comes out front, but there's so little left to integrate, I'm just going to do it. This is a one-step, and you're done. What's the antiderivative of cosine? See, I heard negative and I heard sine. That's why you really got to make sure you know which one, because one's right, one's wrong. So write that down. Go up the scale from cosine. What's cosine's antiderivative? Sine. Yep, you're working up when you integrate. So this would be sine x plus Carl. Are we good with that? This one is not one you know. I don't know that. You might say, well, the antiderivative of 5 is 5x, and the antiderivative of cosine squared is, and then you wouldn't even know. Plus, you're making up your own rule that says you can do them separately. So it means it must be something on the chart. It is. It's secant what? Yes, this is 5 times secant squared's antiderivative. That's what that is. And the derivative of what is secant squared? Tangent. Do you see how I had to play a little bit? You won't have to play a lot, but you might have to play a little bit. So this would be 5 tangent plus c. All right, we're going to go do the bottom one because I want you to see the importance of the variable change. When we start doing the word problems, guess what that variable is going to be for all of them? T. It's time that's going to change, but you still do it as its own. Like if I asked you what this was, you wouldn't have an issue. It's the same thing. As long as there's a variable match, all you're going to do is say it's theta cubed over 3 minus 2 times. See if you can think it out. You could look at your chart on this because it's a cofunction and they don't need to be memorized. But what do you think the antiderivative of cosecant squared is? Think secant squareds, which is what? We just did it. Tangent, right? Cosecant squared would be cotangent with a twist. Yep. And then who do I need to put on there? Carl. All right, perfect. Next up, you might say, why aren't we finding Carl anymore? Because we're finding general solutions, right? These are just general. So we're going to head right down here, and we're going to solve a first level diffie-q and a second level I'm going to have you guys do. So we'll do this one together. Let's see, make sure you know what that directive means. When it says to solve the differential equation, what does my answer look like? When I'm done, it's going to say what? I want, like not specifics, just like in general. F of x, right? When I'm done, when it means solve, it means I want to know what the original function is. Is this a general or a specific? Yes, specific. How do you know? Yes. I'm sending you through an exact point. So the first thing I do is I say, all right, I need to go from f prime back to f, which means I do need to integrate. And I like you writing this first step, even though you can be successful without it. And then actually physically think about what the antiderivative is of f prime, and you would say it's f. And you would say, well, then this is 3x squared over 2 minus what? X, and then what? Carl, right? Now, once I have it there, I'm going to go, that's a whole family of functions that meets the criteria that it has this derivative, but now I'm going to be very specific and make sure it goes through that point. You guys go do the arithmetic for me. Put in a 3 for f of x and a 2 for x, and give me a minus 1. Can someone else back a minus 1? Yeah, all right, we've got lots of them. So my specific solution would be 3x squared over 2, right, minus x minus 1. Let's talk about some things about this function. Are you ready? I've got some good questions coming at you. What's its derivative? Yes. What point does it go through? Is it concave up or concave down? For 2 reasons. Give me one of them. F double prime is 3. Or you know this is a parabola that opens up. Either way, see, it's some good stuff. I like you guys. All right, go do the next one. When you're done, your answer should be f of x. F of x needs to have the second derivative of 2x. First derivative has to sail through negative 530. This one gets messy, by the way. I'm going to walk around and count how many people made arithmetic mistakes, because that's going to be your nemesis for integration. It was 7 in my third hour. They all did the calculus right, every single one of them. So your answer's kind of ugly, and I want you to deal. Is the next page in your notes 4 or 5? Can someone just flip, or is there more to this? It says 4. Oh, perfect. Then I'm ready to hand out your worksheet while you're working. I'm going to basically give everybody enough time to finish this one because I want to count up how many people. See if you can beat my third hour. 7 mistakes in arithmetic, which you would think isn't very many. That was a third of my third hour. I'm going to actually turn this off. People watching the video, you can do it on your own. It's an ugly negative fraction for ultimate Carl.